Hello guys, welcome to the really exciting video. Uh, Data engineering question, a PySpark question asked in a Microsoft interview. So it will be a very interesting question. Let's begin. Now we have one table, input table. It shows like employee ID, experience, and salary. We have three fields, and now here is the criteria on which we need to write a PySpark code. Okay, a company wants to hire new employees. The budget is 70,000. Okay, now here comes the criteria. Criteria number one: keep hiring seniors. Here you can see in the experience column we have two types of people, junior and senior. Okay, keep hiring. Now company wants to keep hire senior people with the smallest salary first until you cannot hire anymore. What does this mean? Now we have the budget of 70,000. These are the three senior people over here. Let's start from the very uh, what we can say cheapest employee. $16,000 plus $20,000, it will be like $36,000. Now if we add $50,000, it will exceed 70,000. So we cannot take this employee ID 6. Okay, we will have to take 16,000 and 20,000 only in our output. As you can see, here are two people. One is 16,000, 20,000. Yeah. Now the second is use remaining budget to hire the junior with the smallest salary first until you cannot hire more. How many? How many more? Now 36,000 is gone. Okay, how much is left? What we get the 40, 50, 60, 70. Now 34,000 more is left with us. Is it 40, 50, 6? Yeah, 34. So let's begin. What is the cheapest employee, junior employee is 10,000. Okay, this we can hire. Next is 15,000. 25,000 is gone. Now can we hire 40,000 salary junior? No, we only had 34,000. So these both are in the output, as you can see. Now it may look like little complex. I will break it down in a very simple. I will explain in a very simple way. So let's forget the criteria first. Okay, we will solve very simple question which says like let's forget this experience tab, and now a company has 70,000 budget. How many people they can hire irrespective of the experience? Okay, it's very simple. Now what? Yes, you guessed it right. What we'll have to do? We'll have to do just okay. Let's here we can see we will just remove this column. Okay, clear content. Now we have only two columns. Now what we will do? First we will sort this salary column. Okay, sort by smallest to largest. Okay, now it is sorted. And now the second thing that will come in your mind will be like let's start counting like 10,000 is gone, 10,000 plus 15,000 is 25,000, 25,000 plus 16,000 is like 36 plus 35 plus 6 is like 41,000. Now if you can see we are just calculating the running sum over here. Okay, once we have the running sum, what we will do, we will filter like on this row we will filter which is less than 70,000, and that's the output. Now we will use this very same idea over here. Now only thing that changes in this and it became complex is due to this experience tab. Okay, now what we were doing here, we were able to find the running sum. We were finding the running sum on the complete table. What we will do over here, we cannot find that we cannot do that thing. So we will need to do the running sum over for seniors differently and for juniors separately. Okay, once we do that, okay, now I will show you what we can do. First we will calculate the running sum based on junior first. Like junior running sum is different and senior running sum is different. as you can see, 10,000 plus 15,000 is 25,000, 25,000 plus 40,000 is 65,000. Okay. Now for senior the running sum will be different. This is 16,000, 16,000 plus 20,000 is 36,000, 36,000 plus 50,000 is 86,000. Now we will what will be the next step? I want you to imagine, I want you to guess it or think about it. We are going to solve this with very this same manner. Okay, we will just break down this table into two data frames. We'll filter it for junior separately and senior separately. Okay, now it will become very easy. Now we will just filter on first. We will take a senior a table for seniors, and we will try to filter it. Running sum should be less than 70,000. Okay, and we will, one thing we will keep in our variable is what is the max running sum over here. We are going to use it in trying to find the junior for the same thing for the junior table. Okay, now for the junior we will calculate this. What we will do, we will subtract this value, this max value from 70,000, and remaining we will pick over here. We will put that filter over here. When I will write the code, you will understand it more easily. Okay, this simple. Now we will take the two tables and we will do the union of them. Bas, that's it. Now let me take you to the data frame. Data bricks. Okay. Now these are few things we need to import. There's a couple of things, and this is the thing which what I have done. I have created the same table. I will give you this code so that you can also generate this same table over in Databricks or wherever you want to generate. Now we will go to our Excel first and see what is the first step. First step is the running sum. Now let's start to code the first step. Yes, this is the favorite part. First thing, we will need to generate the window. Okay, window spec is the variable name. Now we will start with window dot partition by, you remember we need to partition based on this experience. Okay, partition by, now we will put x. Okay, why we are writing it? Why just copy paste over here? Okay, now we have partition by experience. What else do we need? Okay, we will also have to define rows between, but I think by default it will be unbounded preceding and the current row, so I think we don't need to do that. Let's see if we face any issues. Okay, let's run this. This is our window. Now we will just calculate. We will create a new column. Okay, using this data frame. This is our data frame df.can_candidate, and we will take this data frame. We will create a new column called as running sum. Okay, with column okay, running sum. Now for running sum, one thing I would like to show you while importing this sum. I have given this variable as alias as underscore sum. Okay, because sometimes it faces the issue, it don't know whether to pick this sum from this PySpark or the Python itself. Okay, and that will create an issue. It will give the error, this column is not iterable, when it will pick the Python sum. So that's the reason I am going to use this alias, so there is no more confusion. Now sum on what? Sum on this salary. Okay, for the running sum we will calculate the running sum on salary. Okay, so call salary. Okay, now we will have the over clause. Okay, and we already have created a window spec over here. This is the window spec. Now we will put it into the other data frame called as, let's give it a name, running sum underscore df is equals to this, and we'll also try to display the results. Okay, dot display and see if we face any issues. Okay, it is not allowed to use window functions inside aggregated function. Okay, please use function in the subquery. What is the issue it's facing now? It is not allowed to use inside aggregated function. Okay. You might also face some kind of similar kind of issues. So let's try to find out what is the issue. Okay, I don't think, okay, oh my god, this is the issue of this brackets, I guess. Yes, I was right. So we have not given here, we have not closed this sum, we have put the sum function over all this. So yeah, that's the issue. So here we have running sum for junior differently and for senior differently. Okay, I don't see it is a running sum. Oh, so the issue is, yeah, the issue is by default it is not like the rows between concept. If you have heard, you surely might have heard the rows between, we need to give the rows between, we need to define the range for this. Now this is calculating for unbounded preceding and unbounded what we can say posting. So we will just define rows between function and it should solve the issue. Give me 1 second, guys. I'm just bit rows between. Now this is window dot bounded. Okay, we can use this recommendation, comma, window dot, we want current row. Okay, now this will solve the issue. Oh my god, we have another issue now. Window dot, it should be rows between, not row between. Yeah, now this will solve this. So it's a very good thing we are facing these issues. What happens, like once you see someone facing issues and resolving it, you get the confidence to do the same. Okay, now we can see for the juniors we have this 10,000, 25,000, 65,000. Similarly for the seniors we have the running sum. Now what was our next step? Our next step was to create 2 data frames, and the important part will be this, we need to also create a variable. Okay, so first we will create a data frame for seniors. Okay, senior df will be equal to, now what is our data frame name? Running sum.df. We will copy that, we will paste it over here, we'll apply dot filter. Now we will do what we want. Experience should be senior. Okay, column, we will copy this from here, right to right. When we can copy, will be equal to senior. And one more thing, guys, one more thing, what we will need to do is we will also need to write the condition for it should be less than 70,000, correct? And now, and we will come and column running sum should be less than 70,000. Okay, less than 1 2 3. That's it, guys. Now we will try to display this senior df chart display. Yep. Okay, we are getting lots and lots of issues today. It's a good thing, by the way. Has no attribute get object. Okay, so get object ID. Okay, data frame dot filter. What has gone wrong? Unmatched. Oh, here should be one. Okay. Yes. So we are making frequent mistakes of this brackets and all. Okay. Now we have this senior df. Now somehow we need to take care. We need to note this. What is the max running sum? Okay. Now for that, calculating the maximum running sum, we will use senior underscore df. What we will aggregate this, and we will aggregate on this column, and we'll just find maximum running sum. Okay, dot agg max of column we will copy running sum. Let me give dot alias as a max running sum. Okay, now let's see what will happen. Let's do dot collect. Let's just see the output. Okay, now it is getting now we are getting a data frame which says max running sum is equals to 36,000. We only need the output should be 36,000. Okay, now we will simply use 0 and name running sum is not defined. We have to put inside this. We need to also warning running sum. Error running sum. Okay, we need to use this. Okay, not that. My bad. Now it should work. So what we will do, we will, okay, now we are getting 36,000 as an output. Now we will store it inside a variable, and we will give a variable name. Okay, why is it not clicking over here? Just clicking now. Max senior running sum. Okay, that's it. We will store inside a variable, and now we'll also try to print it so that we know. Yeah, we're getting it. Now let's move on to the junior, or you can say junior data set. Yep, junior df will be equal to, now we will going to use the same running some df. Okay, running some df dot filter. Now we will write goals column will be experience, and that should be equal to junior. Okay, and the other condition would be, guys, now running sum should be 70,000 minus 36,000. Okay, now we will write the same thing over here. We have already done the hard work of calculating 36,000 value and storing it inside a variable, so now we have to just use that particular part. Running sum was the variable name, if I'm not wrong. Let's see if it's something. So okay, should be less than 70,000 minus, now this is the very important step, guys. It should be 70,000 minus this. Okay, it ran without any errors. So now let's display this data frame. Okay, now display. Great. So now we have two data frames. One is junior and one is senior. If we go to our Excel, we are done with this step 2. Okay, this was like little tricky step to also we need to also store this variables. So yeah, now the third step is very simple. We just need to do the union of both the data frames. Okay, now let's just complete our answer. We will use a junior data frame first because it was first, like in the input we were having junior first. Okay, so we will use this union. Now for union we will use senior data frame. Okay, this one. That's it, guys. It will be very simple. Now I will give it final answer equals to this dot display. That's it, guys. Now we finally got the answer. We can check, we can recheck it in our 1 2 4 5 1 2 4 5. So yeah, that's it, guys. Please like, comment and share and let me know. It's a good thing we are facing the issues while I am writing the code. Like same issues you might face, and once you see that someone is struggling and he is trying to find out the issues, so this is the natural thing. This is the day-to-day life. We do that in day-to-day basis. So yeah, that's it, guys.